Good morning, geometry class. Hope everyone's doing well. Everyone did an excellent job on their pace test for 11-18. So we're going to get ready to begin a new pace. And so we have two more left for this year. We have pace 11-19. Pace 11-19. Some of you guys and girls have not yet come to pick it up, so be sure to contact me. You need to come get pace 11-19, so be sure to do that tomorrow as quickly as possible. All right, so we're going to get into this new pace. A little bit of review. This is something that you've learned in algebra last year, and something you'll see in Algebra 2. Some of you students will have Algebra 2 next year. You'll see this in Algebra 2. So we're going to kind of look at the goals of this book, what we want to have mastered by the time we get to the self-test. And so first of all, we want to learn on page number 1, we want to learn about the coordinate plane. We're going to learn about that in the first section of this book. And so what is a coordinate plane? How does it function? What is its purpose? We'll learn that. Second goal is to be able to use the distance and midpoint formulas. We're going to learn those formulas. Those formulas will have to be memorized. To use the slope of a line in graphing equations and to apply to the slope-intercept form to graph equations. To be able to determine from the slope if lines are parallel or perpendicular, and to learn how to graph circles. And so all through this pace, that's kind of where we were headed, and so we want to master each one of those techniques. By the time we get to the end of the pace, we'll be applying all of these principles in being able to apply the coordinate system in geometric proof. So looking forward to this pace. It's a good one. I always love starting a new pace, so this will be a lot of fun. So let's look at coordinate geometry, page number 2. Page number 2 in your pace, coordinate geometry. We'll just read a portion of this, and then we'll go on. In about 300 BC, a Greek mathematician named Euclid wrote a book on geometry entitled The Elements. Because of his logical manner of presenting the subject, Euclid is known as the father of geometry. The Elements have been a model for geometry textbooks for over 2,000 years. But the first major change in geometry since Euclid wrote The Elements was the discovery of coordinate geometry in the early 17th century. This new discovery did not replace Euclid's Elements, which is still a very important part of geometry. It just added to it. Coordinate geometry is an area where geometry and algebra meet. René Descartes is credited with the discovery of the principles of coordinate geometry. In honor of his discovery, the coordinate system we use today is called the Cartesian coordinate system. Sometimes you'll hear referred to as the Cartesian plane, okay? Cartesian plane in honor of Descartes. Coordinate geometry became the springboard for Isaac Newton's discovery of the principles of calculus. Now, if I could draw your attention to the picture in the bottom, in the middle of your page number 2 there, perhaps you have seen maps that use a coordinate system to show where a street or city is located. This map is divided into squares. The squares are numbered at the bottom beginning with 1, and the alphabet appears along the side of the map beginning with A. So if you can draw your attention to this map here, so we see how the bottom is numbered from 1 through 5, and the side we have A, B, and C. If I wanted to find any location on this map, I simply would find where the number and the letter would meet. And once we find the space, and so for example, if we're looking at A5 or B4, and so you would line it up, and right where the two meet, you would find the location on the map. And so we see this, this Cartesian coordinate system is similar to this example. There's one change you should be aware of as you begin this pace. We will use only informal proofs to prove theorems. Informal proofs are a paragraph form and are used in upper level math courses. With a solid foundation of formal proofs, we've already kind of mastered that. You should have no problem following informal proofs. So let's turn to page number 3, and let's get into what a coordinate plane is and some characteristics and some facts about the coordinate plane. If you look at the very top picture in your page there, you'll see a picture of an atlas. Okay, it's a picture of the world, and you'll see a grid. All right, so you see squares, you see lines going down, and then lines going across. Okay, cartographers have divided the map of the world into a graph. The horizontal lines on a map are called the lines of latitude. So horizontal, okay, so left to right, horizontal lines are lines of latitude, and the vertical lines, lines up and down, are called lines of longitude. Okay, so latitude, horizontal, longitude, vertical. As a matter of fact, and say, well, how do they use this this chart, this graph? So if a ship is struggling, if a ship is sinking or in danger anywhere in the world, the ship could send its coordinates. And so it would send an SOS, and it would give the coordinates of the location of the map, and the Coast Guard or any rescue boat can find and pinpoint that struggling vessel by knowing the exact coordinates. The military uses it, sailors and ships and all these use the Cartesian map and cartographer. So any place on Earth can be located if the latitude and longitude can be determined. Just as latitude and longitude are used on maps, in geometry, so here's the connection from the real world cartography, all right, Cartesian plane to this coordinate plane in geometry. When two number lines are perpendicular, a coordinate plane is formed. Okay, so we have two lines that are perpendicular. Okay, two lines that are perpendicular. So two perpendicular lines, we have a Cartesian plane or a coordinate plane. Now, these two perpendicular lines are two axes. The point of intersection of these two axes is called the origin. Now, I want you to highlight that. You need to make sure you highlight the origin. So the point, the intersection of these two perpendicular lines is called the origin. Each axis, okay, so axis is plural. Axis is singular. So each axis is a number line with its 0 point at the origin. So, okay, if this, we're going to make this 0, okay, so then here would be 1, 2, 3, 4, 5, 6, 7, 8. Just simply a number line. On the left of the number line, and remember, on the left of a number line, the left of 0, what kind of numbers do we get? Negative numbers. So on the left-hand side, we go -1, -2, -3, -4, -5, -6, 7, 8, and so on. Okay, above the number line, so we go +1, 2, 3, 4, 5, 6, 7, 8, 9. Then below we go -1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so anything to the left of 0 is negative, anything below 0 is negative, anything to the right and above 0 is simply positive. Now, I want you to know this. Now you get ready to highlight this. The horizontal axis. So the horizontal axis, so we're going left to right. The horizontal axis is known as the x-axis. The x-axis. You want to highlight that in your textbook there, right across from figure 1. Right across from figure 1. All right, so we have the horizontal axis is the x-axis, and the vertical axis is the y-axis. All right, so again, class, the horizontal, okay, this is a coordinate plane. All right, so we have two lines that intersect. The horizontal axis is called the x-axis, and the vertical axis is called the y-axis. Very good. You want to make sure that you highlight them. Now that we have these two lines here do intersect, these two intersecting lines form 4 quadrants. 4 quadrants. So we have quadrant 1, we have quadrant 2, we have quadrant 3, and we have quadrant 4. Okay, so 4 quadrants. Now, these quadrants are very important to understand. Okay, so obviously we're seeing here, we're going counterclockwise. Okay, so if a clock normally would go this way, we're going this way, counterclockwise. Now, each one of these are very important. Now, anything to, okay, let's look at this here. All positive values of x are to the right of the y-axis. All negative values of x are to the left of the y-axis. All positive of y are located above the x-axis, and all negative values of y are below the x-axis. So you say, what in the world did you just read? Okay, so let's just hear. In this upper quadrant, in quadrant number 1, since it's above 0, and since it's to the right of 0, we have both numbers would be positive. So the first quadrant, always positive. Now, okay, quadrant 2. Since quadrant 2, since it's it's to the left of 0, okay, so to the left of 0 would mean what? On the number line would be negative, okay. Since it's above 0, it would be positive. Now, moving to the third quadrant, okay? Now, the third quadrant, okay, it's to the left of 0, which would be positive or negative. Good. It would be negative. And since it's below 0, what would it be? Positive or negative? It would be negative. Very good. Now, we come to the fourth quadrant. So in our coordinate plane, okay, we're going to see that the coordinates are going to be made up of two numbers. Quadrant 1, it would be both positive. Quadrant 2 would be negative, positive. Quadrant 3 would be negative, negative. Quadrant 4, okay, now let's look at quadrant 4. Quadrant 4, is it to the left or right of the y-axis? It is to the right. So therefore, it would be plus. And is the fourth quadrant above or below 0? Very good. It's below 0. So any number below 0 would be what value? Negative. And so here's what you see in the quadrant. So quadrant 1, all positive. Quadrant 2, negative, positive. Quadrant 3, negative, all negative, negative, negative. And then quadrant 4 would be positive, negative, okay? Now, to find a point on the coordinate plane, we become acquainted with an ordered pair of numbers. These numbers, which indicate the location of a point on the coordinate plane, are called the coordinates. So if I ask you to find the coordinates, you're going to be given two numbers. We need to find where those two numbers would intersect on our coordinate plane. And so when you see a pair of ordered numbers, you're going to see two numbers such as that, okay? Or we can go to 5, or 0, 1, or -2, -2. These are called ordered pairs. Ordered pairs, okay? Or coordinates. Now, I want you to pay attention to this. This is very important. So you're going to make sure you need to know this, okay? So you'll see on the last paragraph, you're going to look at two bold print. You're going to see the abscissa and you're going to see the ordinate. I want you to highlight both of those terms there. They're something that you're going to need to memorize and know throughout. Because these coordinates are going to be listed as x and y in this order. The first term will always represent the x. The second term will always represent the y. Okay, now the x-coordinate, okay, if you look down in your notes, again, you want to highlight this, is referred to as the abscissa. Sounds like you have an abscissa tooth, right? Abscissa. That's the first one here, so let's point this here. Okay, the abscissa, and then the y-coordinate is called simply the ordinate. All right? So the abscissa and the ordinate. You need to know that. So we're going to refer to them as the abscissa and the ordinate, so you need to make sure that you understand, okay? So again, the first term is called the abscissa, which is the x term. The second term, which is the y coordinate, is also known as the ordinate, okay? The ordinate. Now, let's turn the page. look at the top of this page, okay? Look at the very first sentence, very important sentence. I think that'll help us out when we're looking and graphing and searching for these coordinates. When locating the coordinates of a point on a graph, locate x first. So we want to locate the x, the abscissa, first, and then we will locate the second term, the coordinate, the ordinate, okay? So always look for x first. Now, I want you to do numbers 1 to 7 on your own on page number 4. Let's look at number 8 together. Number 8 together, okay? Number 8, we have a coordinate plane, so I'm just going to kind of erase my quadrants here, and we'll work on this together. Okay, now, again, when we're giving these coordinates and we're asked to find them, we want to locate the x, the abscissa, first. So in number 8, the following coordinates identify the locations of a ship in trouble. Plot where they are located. Now, I don't have a graphing paper here done, so we're going to try to do this, the best I can here. Now, let's look at number 8, okay? Letter A. We want to locate 1, -2. 1, -2. So, again, here's our x and y. So, 1 and -2. Now, which coordinate do we want to locate first? The abscissa. Very good. So, 1. Now, since it's positive, would it be to the left? Now, it's x. So, remember, the x is always the horizontal line. So, since it's positive, would it be located to the left or to the right of the 0? To the right. Okay, so we're simply going to go here. So, here's 0. So, 1 spot to the right. Okay, now the y coordinate, or the ordinate, okay, since it's -2, do we go up above 0 or below to -2? We go down. Very good, below. So we're going to go again. So y is down. Now pretend that there's a line that's kind of going through here, right? And this is kind of what your graph would kind of look like with squares. Again, forgive me for not being straight. But, so we're going to go 1 spot over and 2 spots down. So right where those lines intersect will be our coordinate. So we're going to mark that off there. So it would be 1 over and 2 down. And then I always write my number next to it. So -1, 2. Okay? Let's look at number 9. -5, -1. Okay? -5, -1. So, -5. Since it's, remember, the first coordinate we're looking for is our abscissa. That's the first one we want to locate. So, -5 would be left or right to 0. It would be left, okay? So, we're going to go 5 spots over. 1, 2, 3, 4, 5. And then -1 would be 1 spot above or below 0? Below. So 1 spot down. So we would go 1, 2, 3, 4, 5, and 1. So, and again, since it's negative, we know that if both coordinates are negative, then we know that it's going to be in our third quadrant because our quadrant is negative. All right, let's look at number 10. Number 10. So we have 4 and 7. 4 and 7. Okay, locate the x first. So locate the abscissa. So since it's positive, we're going to go 4 spots to the left or right of 0. To the right. So 1, 2, 3, 4. And then, since it's a positive 7, do we go above or below 0? Since it's positive, very good. Since both numbers are positive, we know that would be quadrant 1. So 7 spots up would be 1, 2, 3, 4, 5, 6, 7. And there would be our graph there. There it is. That's how you do 8, 9, and 10. Let's look at 11, 12, and 13. So based on where these coordinates are, let's give the coordinates for these 3 South Pacific islands. Okay, so let's look at number 11. Number 11, we want to go right to where the dot is, number 11. So number 11, we're going to count four spots over to the left. So -4, and then let's see here, 2 spots down. So for number 11, the coordinates would be -4, -2. Again, you can see where it's located. It's located in the third quadrant. If it's located in the third quadrant, we know both coordinates are negative. Okay, located there. Number 12. Number 12. Now notice number 12 is located in which quadrant? Good, quadrant 1. So in quadrant 1, we know both are going to be positive. So what would be for number 12? Give me the answer for number 12. Good. 2, 4. Very good. 2, 4 would be for number 12. And then for number 13, again, located in the quadrant 1. So we have, always locate the x coordinate, the abscissa first. And so we have 4. And now, since it's not going up at all, it's still on the 0. Okay? It's still on 0. So then we would have 4, 0. It did not go up or down. It stayed on the x-axis. All right, hope that's pretty made simple for you. Hope you understand that. All right, we're going to look to page number 5 now, the distance formula. The distance formula. Okay? Now, how can I measure the distance between two coordinates, okay? And so we're going to find the distance between any 2 points on the coordinate plane by using the absolute value of a number. Now, we remember the absolute value of a number, okay? So, obviously, every number has an opposite number. So, a positive 1 is, the opposite value would be -1, right? And so, the opposite value of -1 would be positive 1. So, now, for any pair of opposites, the positive number is the absolute value. When I say the absolute value, that is just simply the number of spots it is from 0 on the number line. So, all right, quickly here. All right, here's the number line. There's 0, 1, 2, 3, 4, 5, -1, 2, 3, 4, 5. Now, so this spot here would be -5. But since -5 is 5 spots from 0, the absolute value of -5 would simply be 5. The absolute value of +5 would be 5 because it's 5 places from 0. Okay? And so there is no opposite. So the symbol for the absolute value is simply 2 parallel lines. So if I asked you what is the absolute value of -5, right? So the absolute value of -5 would simply be 5. Okay? The absolute value of +5 would be 5. 5 spots from 0 on the number line, okay? Now, the distance between 2 points having the same y-coordinate. Now, here's the key. If we're going to find the distance between 2 points, if they had the same y-coordinate, what's going to happen here, okay? All right, so the distance between 2 points having the same y-coordinate is the absolute value of the difference between the 2 abscissas. Okay, so, all right, now again, abscissa. Okay, I'm just going to denote we have 2 sets of points here, okay? Now, if we have the same abscissa, if we have the same, all right, so, excuse me, the distance between the 2 points having the same y-coordinate is the absolute value of the difference between the 2 abscissas. So, if these are the same number, to find the distance between these 2 points, we would simply take the absolute value of the difference. The absolute value, so we know the difference is subtraction of the 2 abscissas. So we would go x2, you can see this in your book here, minus x1. All right, so if I want to find the distance between 2 points and they have the same y, then the y, this coordinate y is the same number, then all I'm going to do is subtract the two abscisses. Okay, so you'll see this in your book. You want to highlight that. All right, that's the distance if we have the same y coordinate. Now, if we have the same x coordinate, what do you think it would be? The absolute value of the difference between the two ordinates, or the y number. What am I highlight those? So how do I find, here's the key, because in the very next page, we're going to look at how do I find the distance between coordinates that are different values. But for this page, we have, hey, if the y numbers are the same, okay, if the ordinates are the same, then we simply subtract the abscisses. If the abscisses are the same, we simply subtract the ordinates. Let's practice this, okay? All right, let's look at number 1 quickly. What is the absolute value of -9? Good. It's just simply +9. It's just +9. What is the absolute value of 2 minus 9? So, quickly, so 2 minus 9 would be -7. And then what is the absolute value of -7? It's +7. Very good. It's +7. Let's look at number 3. What is the absolute value of 13? Good. 13. It's just simply 13 spots from 0. And then how about what is the absolute value of number 4? We have -6 plus 9. -6 plus 9. Okay, -6 plus 9 would be 3, and the absolute value of 3 would simply be 3. Excellent job here. All right, number 5. All right, plot these points and find the distances between them. So we want to do two things. We want to plot them on the coordinate plane, and then we want to find the distance between them. So, all right, let me quickly draw our coordinate plane. Use a different marker here. Okay. All right, here's the y-axis. Here's our x-axis. All right, we have 0. Okay. Now, let's graph -3, 4. So we're going to graph -3, 4. So -3, okay, since we always go the abscissa first, so -3 would be to the left or right of 0. To the left, very good. So 1, 2, 3 spots. And then the second number is 4. Since it's positive, we're going to go up 4 places. So 1, 2, 3, 4. All right, and then I'm going to write our graph there, -3, 4, okay? All right, now, let's graph B. B is +5, 4. +5, 4. So 5 spots to the right, 1, 2, 3, 4, 5, and then 1, 2, 3, 4. We have 5, 4. Okay, now what we want to do is find the distance between those 2 points. Now, since they have the same y number, since they have the same ordinate, all right, so we're going to find is D equals the absolute value of the difference between the two x, the abscisses. So, which is 5. Now, I want you to notice here, okay, in the formula we have a minus sign, but here we have a -3. So you want to make sure that you pay attention to your sign. So I'm going to put the sign in there, -3. Okay, now we have 2 negative signs, make a positive. So the absolute value of 5 plus 3 Okay, and 5 plus 3 is 8, and the absolute value of 8 is 8. So what is the distance between point A and point B? The distance between point A and point B is simply 8. Very good. Let's look at number 7. We'll do number 7. Do number 7, all right? So C is negative 2, 4. Negative 2, 4. So let's, all right, we'll do this and we'll be finished here. So negative 2 would be, all right, negative 2 spots to the right. And negative 4 would be 4 spots down. So, all right, so negative 2, 4. And then we have D, which is negative 2, negative 1. So negative 2, negative 1 would be right there. Okay. What is the distance between those points? Now let's pay attention here. What do we have the same? We have the same abscissas. So if I have the same abscissa, then I want to simply subtract the ordinates. Okay, so D equals the absolute value of our ordinates. So the absolute value of, okay, we have negative 4 minus negative 1. Make sure, again, you pay attention to your subtraction signs and negative signs here. All right, so we have negative 4 plus 1, right, because two negatives make a positive. And then negative 4 plus 1 would be negative 3. And then the absolute value of negative 3 would simply be 3. That is correct. 3. All right, this will conclude our class for this morning. And so again, for homework, I want you to complete page number 4, and I want you to complete page number 5. Complete page number 4 and page number 5. Thank you so much. Have a great day.